Alright, so this is the end of section 2.3. It's the fourth time I'm doing this video, so it better be pretty darn good. The first time my lecture just wasn't that good. Actually, one of the problems, I made a mistake when I was solving it, and it just went on forever with me making and fixing my mistake. And then the second and the third time I had computer glitches, which, like, I shot the whole video and I thought it was decent and didn't wind up recording. And so this is my fourth time. Hopefully I've got it perfected and my computer doesn't mess up on me. So we have 3 evens and 3 odd problems left. The instructions for each of the problems have a part A and a part B. The part A asks me to find all values of x where the tangent line is horizontal, and we've done that in the previous couple sections. To do the part A, basically we have to find the values of x where the derivative is equal to 0. And so I'll do that first for problem 48, and then I'll talk about part B. So for 48, to find the values of x where the tangent line is horizontal, the first thing I need is the derivative of my function. Because there's a parentheses with an exponent, I'm going to use the chain rule and kind of the shortcut to the chain rule. So I'm going to bring the exponent of 2 and bring it out front. I'm going to leave myself some room. I'm going to lower the exponent from 2 to 1. And I'm going to keep the contents of the parentheses the way they were in the original problem. Where I left that room, I need to take the derivative of each term inside the parentheses. The first term is an x to the first power term. The derivative of any x to the first power term is just its coefficient. So the derivative of 3x is 3. The minus 4 doesn't have an x, that's considered a constant, and the derivative of any constant is 0. So this is 3 minus 0 for the derivative. The derivative is just 3. And I probably can clean this up just a little bit. Specifically, I can multiply the 2 and the 3 together, and I probably don't need to write the exponent of 1. So now I have a derivative. I'm going to now set the derivative equal to 0 and solve for x to finish up part A. So the derivative is 6 times 3x minus 4. So this is both factored and set equal to 0. So I'm going to split each of the factors up, the 6 and the 3x minus 4, and set each one separately equal to 0, because when you have something that's factored and set equal to 0, you split the factors up and set each one equal to 0 to get the values that you need to have. The first 6 equal to 0 doesn't have a solution because there's not an x. The 3x minus 4, to solve it, set equal to 0. First you add 4 to both sides. That will give you 3x equal to 4. And then you divide both sides by 3, and you get x equal to 4/3, which is a fraction, but it turns out to be not the worst fraction in the world when it comes to do part B. So my answer to 48a the values of x where the tangent line is horizontal is x equal to 4/3. Now when I move on to part B of 48, I have to read and figure out what the instructions tell me to do. And on 48b it says find the equation of a tangent line of the graph for the values of x found in part A. So to get an equation of a line, or an equation of a tangent line, I need a point and a slope. So the x coordinate of the point is going to be the x that I just figured out in part A, which is 4/3. I don't have the y coordinate of the point. I'm going to have to do some work to find it. But I actually have the slope that I need, because any value that you set a derivative equal to, when I set the derivative equal to 0, the number that I set the derivative equal to, that is the slope that I'm trying, that I get. So when x equal to 4/3, the slope is 0, because horizontal lines have slopes of 0. So I'm trying to find an equation of a line for part B. I have from part A the slope of my tangent line and the x coordinate of a point. Now I need to get the y coordinate, and to get this y coordinate I'm going to go to this function and plug in 4/3 for x, and I'm going to do that on my calculator. I can do it in my head. It's not so impressive to do in my head, but I'll use my calculator to get that value. And whatever this comes out to be, I'm going to put right here next to the 4/3. It's going to turn out, it's going to come out to be 0, but I'll do that so you can see it. So on my calculator, I'm going to go parentheses, 3, and then times 4/3, which I'll do in a parentheses, 4 divided by 3, and then minus 4, close out my parentheses, and hit the x squared key. So that's essentially what I have written in the parentheses. When I add equals, I get 0 for that. And so because this comes out to be 0, when I plug a value into the original function for x, I get a y coordinate of a point. So now I have a full x and a y point and a slope. So I can use the formula y minus y1 equals m times x minus x1. I could be lazy if I want to, because anytime the slope of a line is 0, the equation of the line is going to be y equal the y coordinate of the point that it's passing through. The answer to this is going to be y equal to 0, but I'll pretend I didn't know that shortcut. So I'm going to go y minus the y coordinate of the point, which is 0, equals m, which is 0, times x minus the x coordinate of the point, which is 4/3. On the left side, y minus 0 is just y. And on the right side, any number times 0, or any quantity, any factor times 0 is equal to 0. So 0 times the quantity x minus 4/3 is still 0, because 0 times anything is 0. And that's actually the answer for part B. I'm actually done with part B. If I want to check, what generally happens is when you find the equation of a horizontal tangent line, that line passes through a maximum or minimum point on a graph, which is a little peak or valley on a graph. So if I graphed both the original function and the answer should go directly through, actually this graph is going to be a parabola, so the graph of the answer should go directly through the vertex of the parabola. So I'm going to go ahead and graph this just so you can see that you can check it. For checking, I'd go y equals, clear out anything I have in there, and go 3x minus 4 quantity squared. Zoom standard because I have no idea what window I have on. And it'll be a parabola, and the equation I'm going to graph is going to go right through the vertex of the parabola, and unfortunately the vertex is right on the x-axis, so the line that I'm going to draw is going to go right on the x-axis. I'm not actually going to see it so much, but when I go to y equals and graph my answer to part B, y equal to 0, when I graph it, it has to go through the vertex of the parabola, and you're not going to see it because y equals 0 is the graph of the x-axis. But at least it's not going to go somewhere off on the graph that doesn't go through the vertex. For instance, if I would have come up with the answer y equal to -5, and then when I graphed it, I'd graph the parabola, and then the answer doesn't go right through the vertex of the parabola, and that's what you need to have happen. And my answer, y equal to 0, did go through that vertex. You just didn't see it because the vertex was on the x-axis. So that's everything for part A and B of 48. So you should do the same for 47. It should be real similar. And now I'll move on to do 49 and 50, which are a little bit harder because the derivative's a little bit harder. And then the last two problems are actually a little bit easier. So for 50, to do part A, to find the values of x where I have a horizontal tangent, I need to find the derivative. Unfortunately, there's multiplication here, so I need to use the product rule. And I'm probably consistently inconsistent when I do the product rule. To do the product rule, you have to take the two factors. 3x is one factor, x minus 2 equals the other, x minus 2 squared is the other factor. You have to take each factor times the derivative of the other factor. So I need to take the 3x and multiply it by the derivative of x minus 2 quantity squared, and then plus the x minus 2 quantity squared times the derivative of 3x. So the product rule is really flexible in terms of how you write it up. On either side of a plus sign, you need each factor times the derivative of the other factor. The two factors are 3x and x minus 2 quantity squared. So one factor times the derivative of the other factor times the derivative. So of the first factor times the derivative of the second factor times the derivative of the first factor, in any order. So when I go to do my derivative here, I need to leave myself some room. So I need to find the derivative of x minus 2 squared. I'm going to write it in red just so you can see the derivative separately from the problem. Because this is a parentheses with an exponent, I need to use the chain rule. I'm going to bring the 2 out front. I'm going to put it in a parentheses just to separate it from the 3x. I'm going to leave myself some room, and then I'm going to lower the exponent by 1. That's the beginning of doing the chain rule for the derivative of x minus 2 quantity squared. But always in that space where I leave the room, I need to write the derivative of each term inside the parentheses. Inside the parentheses, there is a 1x and a minus 2. The derivative of any x to the first power term is its coefficient, so the derivative of 1x is just 1. Minus 2 doesn't have an x, so its derivative is 0, so the derivative of x minus 2 is just 1. That's the first half of my derivative. I'll simplify it in a second. And for the second half, I take the x minus 2 squared and I multiply it by the derivative of 3x. The derivative of 3x, because it's an x to the first power term, it's just its coefficient. The derivative of 3x is just 3. I probably can pull out a common factor before I multiply this out. And on either side of this plus sign, I see a 3 and a 3. I see an x minus 2 and an x minus 2. So there's going to be a common factor of a 3 and an x minus 2 that I can factor out. The 3, I don't have to worry about pulling an exponent with it, but since there's 2 x minus 2 factors, I'll take the smaller of the exponents, which is x minus 2 to the first power. So I'm going to pull out my common factor of 3 times x minus 2. And then I usually write a square bracket when I pull out a common factor because there's going to be a parentheses inside this, but you could write another round bracket here. Inside this bracket, I'm going to put this x times 2 times 1 that's left over to the left of the plus sign, which eventually I'm going to write as 2x. I'm going to bring this plus sign down. I had an x minus 2 squared. I factored out 1x minus 2, so I'm still left with an x minus 2 to the first. And that 3 I factored out, it's gone. I wrote this pretty poorly. I probably could have written this just as 2x and this just as x minus 2 without an exponent and without a parentheses. I'm going to do that on my next step. So I'm going to get y prime as 3 times x minus 2, and then I'll go back to a round bracket because I'm not going to have a parentheses inside a parentheses anymore, but I could have kept a square bracket. Those multiply out to be 2x. Here, I can drop the exponent and drop the parentheses and just get an x minus 2. And then to finish this up, to the derivative up, I'm going to combine these terms. Here's a 2x. The second x is a 1x. When I combine 2x and 1x, I get 3x. So now I have completed my derivative, but I haven't finished part A of number 50. Part A of number 50 wants me to find the values of x where the tangent line is horizontal. And you do that, you get those values of x by taking the derivative and setting it equal to 0. My derivative is nicely factored, so when I set it equal to 0, I just take the individual factors and set them equal to 0 to get the values of x that I'm looking for. The first factor, because it doesn't have an x, doesn't give a solution. The middle factor, I'm going to add 2 to both sides and get x equal to 2. The last factor, I'm going to add 2 to both sides. That only gives me 3x equal to 2. That's not fully solved, so I have to finish up by dividing by 3. And I'm going to get x equal to 2/3. So my answers to 50 part A that at x equal to 2 and x equal to 3, or x equal to 2 and x equal to 2/3, not x equal to 3, the tangent line is going to be horizontal, meaning it's probably going to go through a high or a low point. Now I'll move on to part B. Because A has 2 answers, part B is going to have 2 answers. Part B is getting the equation of the tangent line. So when I go to do 50 part B, I'm going to get a first line and a second line. The first line has an x coordinate of x equal to 2. The second line has an x coordinate of x equal to 2/3. And I wrote the x's in a point in the x position because I need points to get equations of tangent lines. So I took these two and separated them into points. For each x, I need to get a y value. And just like in question 48, slopes of horizontal lines are 0. So my slopes are going to be 0. Any number that I set the derivative equal to is going to be the slope of the line for that value of x. So my slopes are going to be 0. For each of these x's, I need to get a y. And I'm going to use this equation, 3x times x minus 2 squared, to get my y's. So my first y I need to get is when x equal to 2. So I'm going to go f of 2 equals 3 times 2 times 2 minus 2 squared. That's going to be 0, but I'll do it on my calculator so you can believe me. So for f of 2, second quit, clear, second quit, clear, clear, clear. So I'm going to go 3 parentheses 2 times parentheses 2 minus 2 squared. That gives me a 0. That's the y-coordinate of the point next to 2. For f of 2/3, I'm going to go f of 2/3 equals 3 times 2/3 times 2/3 minus 2 squared. My calculator is going to give me a decimal, and I'm going to math enter to make that into a fraction. So for this one, I go 3, and then parentheses 2 divided by 3, and then parentheses 2 divided by 3 minus 2 quantity squared, enter, ugly decimal, math, enter, and I get 32/9. And that's going to be the y-coordinate of my second point. So now I have two sets of points with a slope. I can go now and get the equations for my lines. Because the slope is 0, the equation of my line is just going to be y equal the y-coordinate of the point. So you should, when you're asked to find equations of tangent lines and you have a point, just write y equal the y-coordinate of the point. But you can do algebra. The algebra would be using the y minus y1 equals m times x minus x1 formula. For this first set of values, I'd go y minus the y-coordinate, which is 0, equals m, which is 0, times x minus the x-coordinate, which is 2. Y minus 0 is just y. On the right side, 0 times x minus 2 is 0. That's how you get that answer for part 50b. For this one, I'd go y minus y1, which is y minus 32/9, equals m, which is 0, times x minus 2/3. And y minus 32/9, I can't simplify just yet. I'm going to leave that y minus 32/9. And on the right side, 0 times anything is 0, so I get 0. To finish this up, to get the answer, if I'm doing it the long way, I'm going to add 32/9 to both sides. On the left side, the y's will the 32/9s will cancel. I'll be left with my y. On the right side, 0 plus 32/9 is 32/9. And again, I can check this by simply graphing the original function, graphing y equal to 0, and graphing 32/9. Each one of these lines should go through a hump. So let me go ahead and do that real quickly, just so I can show you how it checks. So clear, clear, graph 3x times x minus 2 squared for my y1. For my y2, I'm going to graph y equal to 0. And for my y3, I'm going to graph y equals 32 divided by 9. When I do the graph, first it's going to graph the function, which is going to have some sort of wiggle to it. The first line y equals 0, the first line y equals 0 goes right through that hump, which is on the axis, so you don't see that graph. The second 32/9 goes right through that hump, which is perfect, because horizontal tangent lines have to go through humps for the most part. There are other variations of horizontal tangents. They can go through kind of pauses in a graph, but I didn't put any of those because I didn't want to expose you to something that doesn't come up that often, and it's a little too early to bring that up. All right, so you should give 49 a go, and then we just have two more problems left, one each, 51 and 52. So 51 and 52, same instructions. So for 52a, to do part A, find the values of x where I have a horizontal tangent. I'm going to find the derivative. So I'm going to write y prime. I don't need the product rule in 52 like I did in 50 because the 7 doesn't have an x in it. I could simply take the exponent 2, multiply it by the coefficient 7, leave myself some room, lower the exponent from 2 to 1, and where I left myself some room, I write the derivative of each term inside the parentheses. The derivative of 5x, because it's an x to the first power term, is just the coefficient of 5. The derivative of minus 6, because it's a constant without an x, is 0. So the derivative of the inside of the parentheses is just 5. If I multiply this out, 2 times 7 times 5 is 70, and I get 70 times 5x minus 6 for my derivative. To get the values of x where I have a horizontal tangent, I need to take the derivative and set it equal to 0. Because it's factored, I'm going to set each of the factors equal to 0 to get the values of x that I need. For the 70 equal to 0, because it doesn't have an x, it's not going to give an answer that I need to work with. For the 5x minus 6 equal to 0, I'm going to add 6 to both sides and get 5x equal to 6. And then I'm going to divide both sides by 5 and get x equal to 6/5. That's my whole answer to 52a. Now I'll move on to do 52b. So for 52b, I need a point and a slope. The x-coordinate of the point is x equal to 6/5. The slope of any horizontal tangent line is 0. And to get the y-coordinate of my point, which is going to be 0, I'm going to go y equals 7 times parentheses 5 times 6/5 minus 6 squared. Plug 6/5 in for x into the original function. I'm going to get 0 when I do this, but I'll go do it on my calculator so you can see. So second quit, clear, 7 parentheses, 5 parentheses, 6 divided by 5 minus 6 parentheses squared. So that's plugging 6/5 in for x into the original function, and I get 0. So here you get y equal to 0. That's the y-coordinate of my point. I could speed and shortcut the answer, or I could use the formula y minus y1 equals m times x minus x1. They both will work. If I use this formula, I get y minus 0 equals m, which is 0, times x minus 6/5. On the left side, y minus 0 is just y. On the right side, 0 times anything is just 0. And there's my answer to 52b. So again, if I'm going to graph this, the horizontal tangent line is going to go through the vertex of the parabola. This is a parabola because it's an x squared. So if I wanted to check, I'll just go y equals, clear out anything that's in there already, graph the function, 7 parentheses 5x minus 6 squared, graph the answer to part B, and when I do that, I get the function graphed. Well, it's a bad window. It doesn't even look like a parabola because my y's need to be a lot bigger, I think. Let me just make a better window for you. Go y equals, I'm going to make this y up to like 50 so it doesn't look so funky. And still looks so funky. It looks really pointy, but it is a parabola. It's just that my window's not so good. Let me really work on my window more. I'm going to crunch the x's now just to get you a better picture. That's getting better. So it's a parabola, but you needed to really get a window that was unexpected to get a good picture. Nevertheless, my horizontal tangent line, y equals 0, goes right through the x-axis. It goes right through the vertex of the parabola. And that's when you have a parabola, the horizontal tangent has to go through the vertex. All right, so that's the end of section 2.3. Thank gosh. So give 51 a go, and then we'll move on to 2.4.